Hello everyone, welcome back to another video lecture. Today we are going to see another problems on stress strain, as well as we are going to see a different kind of sections. Till now we've seen the solid circular bar or rod, but in this lecture we'll try to do the problematic numericals on hollow cylindrical sections. So let's see the problem. So let's see the problem number 5. So problem 5, let's see the question first. The safe stress for a hollow section, hollow steel column, which carries an axial load. So it says the safe stress for a hollow steel column which carries a axial load of 2.1 into 10 to the power of 3 kilonewton is 125 meganewton per meter square. So this hollow steel column carrying an axial load, and the safe stress is given, that is 125 meganewton per meter. Right? Now if the external diameter of the column is 30 centimeters, so determine internal diameter. Right? So in this question, the hollow steel column is carrying an axial load of 2.1 into 10 to the power of 3 kilonewtons, and the safe stress is 125 meganewton per meter square. External diameter is 30 centimeters. We have to determine the internal diameter. So with this data, we'll try to draw so this is the external diameter. So hollow section, right? And this is the internal diameter we need to find. Right? So what is the external diameter? So the external diameter is given 30 centimeters, right? And the load, axial load, so axial load is nothing but which will act on the axis of this column, right? So that is 2.1 Newton per 10 to the power of 3 kilonewton. Right? So now internal diameter. So this internal diameter we need to find. Right? First we'll try to find out the axial load and the stress which is given, we'll write here the safe stress is given, that is sigma 125 Newton mega Newton per meter square. So mega, we know that it is 10 to the power of 6, that means 125 into 10 to the power of 6 Newton per meter square. So axial load is given, that is P. So P how much? Here P is 2.1 into 10 to the power of 3 Newton kilonewton, right? So that means 2.10030 to 10 to the power of 3 Newton, right? So kilo we convert into newtons, kilonewton we convert into newtons, right? So now we can write that 2.1 into 10 to the power of 3 zeros and 3, it will become 10 to the power of 6 Newton, right? Now the external diameter is given in the question. So that is, let's say capital D is external diameter and this is small d, that is we have to determine. So external diameter is given, that is 30 centimeters. Convert this into meters, multiplied by 100, that will be 0.3 meters. So we know that, so 3 centimeters, so 100 centimeters equal to 1 meter, that is 3 upon 100, so we get 0.3 meters, right? So this is all about the given data. We need to determine small d, right? Yeah. First of all, we'll try to find out the area of the cross section, right? What is the formula for area of cross section for a hollow cylindrical material? So let me write here. So area of cross section of a column A equals to pi by 4 d square minus small d square. So this is the formula for area of cross section for a circular hollow section, right? So that will become pi by 4, the capital D is given, that is 30 centimeters, 0.3 in meters to the power of 2, and d square is unknown. So we know that stress is nothing but force or load upon area. So from this we can calculate stress is given, that is 125. So 125 into 10 to the power of 6, which is equals to, so P, that is 2.1 into 10 to the power of 6 upon pi by 4. Area, we know that 0.30 to the power of 2 minus small d square, right? So let me erase this. Here so we'll write the next. Yeah, so the last step is 125 into 10 to the power of 6, 2.1 into 10 to the power of 6 pi by 4 into 0.3 to the power of 2 d square is unknown. So I'm bringing this part on left hand side, that is pi by 4 0.30 to the power of 2 to d square, that will be 2.1 into 10 to the power of 6, and this will be here 125 into 10 to the power of 6, that will become 0.0168, right? So 0.30 square to d square equals to, I'm sending this here, so 4 into 0.618 by pi, so we get 0.024, right? Here will be same d square. So now from here, so d minus d square equals to, sending this on right hand side, it will become negative 0.0214 minus 0.30 square, and here it will become minus 0.0686, so minus get cancelled, d square equals to 0.0686. From here d equals to under root 0.0686, right? D equals to, we got it, 0.2619 meters, right? To convert this into centimeters, so we'll try to multiply 0.26.1 into 100, that is 1 meter equals to 100 centimeters. So we'll get the value, that is d equals to 25.19 centimeters. So what is the internal dia? That is d equals to 26.19 centimeters. So this is how you can find internal dia when stress is given as well as the axial loading P, right? Now we'll see another problem number 6. If you want to take notes, please pause the video and you can take the notes. Because of this, we are taking a video lecture, so I'm erasing this as soon as I complete. So if you want to write, if you want to take notes, just pause it and have a notes. Right. Next we'll try to write the problem number 6, try to understand the problem number 6. Till now we completed 5 problems, this is the 6th problem. The ultimate stress, so this is the same kind of problem, the ultimate stress is given. So in the previous problem it is given the safe stress, the ultimate stress for a hollow steel column which carries an axial load of 1.9 meganewton. Okay, 1.9 meganewton is 480 Newton per mm square. So here the ultimate stress is 480 kilonewton per mm square, sorry, Newton per mm square, and the axial load, it is carrying an axial load of 1.9 meganewton, right? So next, if the external load, if the external diameter of the column is 200 centimeters, right? Determine the internal diameter, and here in the question it is given takes factor of safety as 4. So let us write the given data. Try to understand the problem. Here again the same internal dia is, we have to determine the internal dia. So what is external dia? External dia is given, that is 200 centimeters, 200 mm. So here it is given in mm. So internal dia we have to find. Okay, so external dia D is given, internal dia small d equals to how much? So that is a given data. So we'll try to write here. So what is the ultimate stress given? So ultimate stress will be 480 Newton per mm square. So now axial load P equals to 1.9 meganewton, right? We know that 10 to the power of 6, so 1.9 into 10 to the power of 6 Newton. I'm converting meganewton into newtons, so mega is nothing but 10 to the power of 6. Now the external diameter, external dia D is given, that is 200 mm. So it is given in mm, no need to convert into meters or mm. So factor of safety is 4. So this is a given data, right? So now first we'll try to find out the internal dia by help of the cross sectional area, right? Yeah. So area of cross section is pi by 4 d square, capital D square minus small d square. So capital D is given, that is 200 mm. So now by the help of this factor of safety we can find out the ultimate stress upon working stress. So what is the formula for factor of safety? We already know, we already studied in previous lectures, that is factor of safety is a ratio of ultimate stress and working stress. Or so working stress, like we discussed, is also known as permissible stress. Permissible stress, right? Yeah. Now the factor of safety is given 4, ultimate load is 480 upon working stress. Or we can take here working stress is equals to 480 upon 4, right? So that is sigma equals to 120 Newton per mm square. So from here we can find out the working stress is 120 Newton per mm square. So now we know that sigma equals to force upon area or load upon area, that is 120 equals to so 19 6 zeros, right? 5 zeros, that is a load upon area by pi by 4 capital D square minus small d square, right? So here one crore 19 lakhs, almost 5 zeros upon pi by 4, here 40,000 minus d square, right? Now 40,000 minus d square, I'm sending on LHS left hand side, that is equals to upon pi into 120, right? From this we got 20159.6, right? Okay, so now d minus d square, send this on right hand side, so 20159.6 upon 4000. So now we got, oh sorry, 5 नहीं जाता है, minus 40,000, right? So how much we got in negative? That is minus 19840.4, right? D square minus get cancelled, D was under root 198,406.4. We'll get D value from here, that is 140.8, right? And the units are in mm. So we got the small d value as 140.8 mm, right? So this is how you can find out the internal diameter when factor of safety is given, as well as the ultimate stress. So that's it for today's class. In the next class, we'll try to understand another problem which is subjected to axial compression. Till now we've seen the axial loading. We'll see some axial applied compressive load. So that's it. Thanks for watching.